Express -8 root 3 I in the form of r cos theta plus I sin. So you want to express this in polar form. Okay. So the first thing you do is draw it, and you position where it is. So it's down here in this corner. So it's -8 -8 root 3. Okay. So that's where this point is. So the first thing to do is find the modulus. Right. So to get the modulus is the square root of -8 squared plus -8 root 3 squared. Okay, squaring that out, you get 16 plus, squaring this out, you get 192. Adding them together, you get 256, and the square root of that is 16. So that's what r is. Second thing is you need to find the angle. Okay, so this side is 8 root 3, this side is 8. So it's tan of the angle, which is the angle here, opposite over adjacent, which is 8 root 3 over 8. The angle comes out to be 60 degrees. Okay, so this angle here is 60 degrees, but that's not the angle we're looking for. We're looking for the angle all the way back from the start, so all the way around to here, down to here. Okay, so what angle is that? Well, that angle is 240 degrees. It's 180 degrees plus the 60. So to put it into polar form then, it would be 16 bracket cos 240 plus I sin 240. So that's it in polar form. Okay. Now, we'll continue on. It says, hence use the Morris theorem to find the four complex numbers such that Z4 is equal to this. So we're going to call Z4 equals to 16 cos 240 plus I sin 240. So I want to find what Z is. Z is equal to this to the power of quarter. Okay, so what happens is a quarter with the Morris theorem? The quarter will land in beside the 16 as a power, and the quarter will land in front of the angle. Now there's one other thing you have to include. You have to include 360n because you want to generate a number of answers. Okay, so you include 360n. So it's quarter 240 plus 360n. Okay, working this out, 16 to the power quarter is 2. Cos of the quarter this then will be 60 plus 90 n plus I sin 60 plus 90 n. Now we want to generate our numbers. Okay, so we generate numbers by calling n equals 0, n equals 1, n equals 2, and n equals 3. Okay, because we want 4 different answers because there was 4 answers with 4 roots. Okay, so we put n equals 0 first of all, so it will be 2 cos, we put in 0, this would just be cos 60 plus I sin 60. Working this out, cos of 60 is a half plus root 3 over 2i. Sine of 60 is root 3 over 2, and this works out to be 1 plus root 3i. So there's my first answer. Second answer is found when I put n equals 1. So it's 2 cos, now if I put 1 in for n, this time I get 150 degrees. Plus I sin 150. Working this out, it's 2 cos of 150 is minus root 3 over 2 plus sine of 150 is a half I. And this works out to be minus root 3 plus 1i. So there's my second answer. So I'm going to fit the other two answers in here. N equals 2 is next. So that would be 2 cos, if you put 2 in for n then, you get 240 plus I sin 240. Working that out, cos of 240 is minus a half. Sine of 240 is minus root 3 over 2i. And multiplying that out, you get minus 1 minus root 3i. Okay, so that's my third answer. And one more answer because you're looking for 4 roots, n equals 3. So this is 2 cos, and if you substitute 3 in for n here, you get 330 plus I sin 330. Working this out, cos of 330 is root 3 over 2 plus sine of 330 is is minus a half I, and multiplying that out, you get root 3 minus 1 I. So there's my fourth root. Now, question is, what will happen if I put n equals 4? Well, they start repeating each other. So n equals 4 will be equal to this answer. N equals 5 will equal to this answer, and they keep repeating themselves. So there's the 4 roots of the complex number.